HTTP methods. HTTP provides a standard set of methods that form the interface for a resource. Since the original HTTP spec was published, the patch method has also been approved. As shown earlier in Figure 1 to 4, the method appears as part of the request itself. N. Extension is a description of the common methods API authors implement. GET retrieves information from a resource. I. If the resource is returned, the server should return a status code 200 OK. HEAD identical to a GET, except it returns headers and not the body. POST requests that the server accept the enclosed entity to be processed by the target resource. A. As part of the processing, the server may create a new resource, though it is not obliged to. I. If it does create a resource, it should return a 201 created or 202 accepted code and return a location header telling the client where it can find the new resource. I. If it does not create a resource, it should return a 200 OK or a 204 no content code. In practice, POST can handle just about any kind of processing and is not constrained. PUT requests that the server replace the state of the target resource at the specified URI with the enclosed entity. If a resource exists for the current representation, it should return a 200 OK or a 204 no content code. However, if the resource does not exist, the server can create it. If it does, it should return a 201 created code. The main difference between POST and PUT is that POST expects the data that is sent to be processed, while PUT expects the data to be replaced or stored. DELETE requests that the server remove the entity located at the specified URI. If the source is immediately removed, the server should return a 200 code. If it is pending, it should return a 202 accepted or a 204 no content. Options requests that the server return information about its capabilities. Most commonly, it returns an allow header specifying which HTTP methods are supported, though the spec leaves it completely open-ended. For example, it is entirely feasible to list which media types the server supports. Options can also return a body, supplying further information that cannot be represented in the headers. PATCH requests that the server do a partial update of the entity at the specified URI. The content of the patch should have enough information that the server can use to apply the update. If the resource exists, the server can be updated and should return a 200 OK or a 204 no content code. As we put, if the resource does not exist, the server can create it. If it does, it should return a code of 201 created. A resource that supports patch can advertise it in the allow header of an options response. The accept patch header also allows the server to indicate an acceptable list of media types the client can use for sending a patch. The spec implies that the media type should carry the semantics to communicate to the server the partial update information. So patch is a proposed media type and graph that provides the structure for expressing operations within a patch. TICE requests that the server return the request it received. The server will return the entire request message in the body with a content type of message /HTTP. This is useful for diagnostics, as clients can see which proxies the request passed through and how the request may have been modified by intermediaries. Conditional requests. One of the additional features of HTTP is that it allows clients to make conditional requests. This type of request requires the client to send special headers that provide the server with information it needs to process the request. The headers include if match, if none a match, and if modify instance. Each of these headers will be described in further detail in Table B2 in Appendix B. A conditional get is when a client sends headers that the server can use to determine if the client's cached representation is still valid. If it is, the server returns a 304 not modified code rather than the representation. A conditional get reduces the net work traffic as the response is much smaller, and also reduces the server workload. A conditional put is when a client sends headers that the server can use to determine if the client's cached representation is still valid. If it is, the server returns a 409. Preconditions failed. A conditional put is used for concurrency. It allows a client to determine at the time of doing the put whether another user changed the data. Method properties. HTTP methods can have the following additional properties. A safe method is a method that does not cause any side effects from the user when the request is made. This does not mean that there are no side effects at all, but it means that the user can safely make requests using the method without worrying about changing the state of the system. An idempotent method is a method in which making one request to the resource has the same effect as requesting it multiple times. All safe methods are by definition idempotent. However, there are methods that are not safe and are still idempotent. As with a safe method, there is no guarantee that a request with an idempotent method won't result in any side effects on the server, but the user does not have to be concerned. A cacheable method is a method that can possibly receive a cached response for a previous request from an intermediary cache. Table 1-to-1 lists the HTTP methods and whether they are safe or idempotent. Table 1-to-1. H. TTP methods. Method safe idempotent cacheable get uses is head uses is post no put no is no delete no is no option size is no. Method safe idempotent cacheable patch no is no traces yes no. Of the methods listed, the most common set used by API builders today are get, put, post, delete, and head. Patch, though new, is also becoming very common. There are several benefits to having a standard set of HTTP methods. Any HTTP client can interact with an HTTP resource that is following the rules. Methods like options provide discoverability for the client so it can learn how those interactions will take place. Servers can optimize. Proxy servers and web servers can provide optimizations based on the chosen method. For example, cache proxies know that GET requests can be cached. Thus, if you do a GET, the proxy may be able to return a cached representation rather than having the request travel all the way to the server. Headers. HTTP messages contain header fields that provide information to clients and servers, which they should use to process the request. There are 4 types of headers: message, request, response, and representation. Message headers apply to both request and response messages and relate to the message itself rather than the entity body. They include headers related to intermediaries, including cache control, pragma, and via. Headers related to the message, including transfer encoding and trailer. Headers related to the request, including connection, upgrade, and date. Request headers apply generally to the request message and not to the entity body, with the exception of the range header. They include headers about the request, including host, expect, and range. Headers for authentication credentials, including user agent and from. Headers for content negotiation, including accept, accept language, and accept encoding. Headers for conditional requests, including if match, if none match, and if modified since. Response headers apply to the response message and not the entity body. They include headers for providing information about the target resource, including ALMO and server. Headers providing additional control data, such as age and location. Headers related to the selected representation, including ETAG, last modified, and vary. Headers related to authentication challenges, including proxy authenticate and www authenticate. Representation headers apply generally to the request or response entity body content. They include headers about the entity body itself, including content type, content length, content location, and content encoding. Headers related to caching of the entity body, including expires. For a comprehensive list and description of the standard headers in the HTTP specific cation, see Appendix B. The HTTP specification continues to be extended. New headers can be proposed and approved by organizations like the Eighteenth Internet Engineering Task Force or the W3C. World Wide Web Consortium of extensions of the HTTP protocol. Two such examples, which are covered in later chapters of the book, are FC 5861, which introduces new caching headers, and the course specification, which introduces new headers for cross-origin access. HTTP status codes. HTTP responses always return status codes and a description of whether the request succeeded. It is the responsibility of an origin server to always return both pieces of information. Both inform the client whether or not the request was accepted or failed and suggest possible next actions. The description is human-readable text describing the status code. Status codes range from 4XX to 5XX. Table 1 to 2 indicates the different categories of status codes and the associated references in this. Table 1 to 2. H. TTP status codes range description reference 1XX. The request has been received and processing is continuing. http://html/html/draft.p2 semantics 21 section 7.22xx. The request has been accepted, received, and understood. http://tools.eth.org/html/draft.p2 semantics 21 section 7.3. Range description reference 3xx. Further action is required to complete the request.http //tools.eth.org/html/draft.p2 semantics 21 section 7.44xx. The request is invalid and cannot be completed. http tools.eat.org/html/draft p2 semantics 21 section 7.55xx. The server has failed trying to complete the request. http://tools.eat.org/html/draft p2 semantics 21 section 7.6. Status codes can be directly associated with other headers. In the following snippet, the server has returned a 201, indicating that a new resource was created. The location header indicates to the client the URI of the created resources. Thus, HTTP clients should automatically check for the location in the case of a 201. http://1.1/201 created cache control no cache pragma no cache content type application/sn SHA-SIT equals at 8 location http://localhost 8081/API/contacts/6 content negotiation. HTTP servers often have multiple ways to represent the same resources. The represent